All right, so now we're really getting into what this unit is about, and that's exponential functions. Okay, your learning goals. I can create a graph from an exponential function, identify if a graph will have an x-intercept based on a given equation, and determine if an ordered pair is a solution for a graph. All right, so let's break down the function, what it looks like and what they mean. So we have f of x equals a times b to the x power. What this means, this right here is going to be your y-intercept, or if you have a word problem, it's going to be the starting amount of whatever it is that you're talking about, whatever the subject of the problem is. And the b is going to be your growth or decay factor. So it's going to be growth if b is less or greater than 1, and it's going to be decay if b is less than 1. Important to note because it changes what the graph looks like. Okay, now as far as like translating an exponential graph, meaning moving it up or down, think back to geometry when we said translating. So everything remains the same except if we add this plus c. Okay, so if c is greater than 0, if it's positive, we're shifting it up that many. If it's less than 0, in other words, if c is negative and this becomes minus c, then we're shifting it down, again, just like we did in geometry. So nothing new there, we're just applying it to a different type of graph. So like if I negative, we'd shift it down. Simple as that. So as far as solving exponents go, let me change the color here to something we can all see. If we had to solve 2/3 to the x power, so basically this is what you do with exponents. 2/3 to the x power, so I'm replacing x with 2. So this would be 2/3 squared. Now when you have this, when you have a fraction that's raised to a power, what you really have is 2 squared over 3 squared. So you're squaring both parts. So your answer for this would be 4/9. Now if we have 2/3 to the first power, okay, anything to the first power is just itself, so that's going to be 2/3. To the 0 power, now this is important. Anything to the 0 power to 0 power is 1. Important to know. So it doesn't matter if it's a fraction or number or negative, positive, doesn't matter. Anything to the 0 power is 1. Now, this is where it gets a little tricky. So we've got 2/3 to the negative 1 power. Some of you might be like, oh, well, that's easy. It's just going to be negative 2/3. No. Okay. What happens is we can't have a negative exponent. So to make it positive, we flip it. So what was the denominator is now the numerator. What's the numerator is now the denominator. So we, in other words, let's use math terms. So we have the reciprocal, and now we have it to a positive 1. So this changes to a positive after we write the reciprocal of the fraction inside. So now the answer to this is 3/2. And then over here to the negative 2, so 2/3 to the negative 2 is actually 3/2 to the positive 2, which is 3 squared over 2 squared, which is 9/4. All right, so that's how you deal with fractions and exponents and negative exponents. So remember, if you have a negative exponent, it flips. So even if that wasn't a fraction in there, let's say that was 2. So I'm just going to use this as another example down here. Let's say you had 2 to the negative 2nd. Okay, what that actually becomes is 1/2 to the positive 2, which would then be 1/4. But just so you know how to handle it, whether it's a fraction or whether it's a whole number. All right, so example 1, we need to graph 3, f of x equals 3 to the times 1/3 to the x power. So we basically, the easiest thing to do is you want to graph at least 5 points. Something to note here. You are never ever, unless there's a translation, unless there's a a minus number, so unless it's been translated down, you are never going to cross this x-axis. It just doesn't happen with exponents. It doesn't even touch it. It may look like it does, but it doesn't. All right, so we would start off, and this is when you have to graph something, I would say pick these 5 numbers. It'll give you the best idea. So when x is negative 2, so we have 3. What happens is we have 3 times 1/3 to to the negative 2. Remember, this part actually becomes 3 to the positive 2. So we have 3 times 3 squared, in other words 3 times 9, which is 27. So that's how I got this. Get rid of that to clear some off. Okay, next we would have 9, because 1/3 to the negative 1 is actually 3 to the positive 1, because we write the reciprocal, right? So instead of 1/3, we make it a 3 to the positive 1. 3 times 3 is 9. Okay, 1/3 to the 0 power, anything to the 0 power is 1, so 3 times 1 is 3. Okay, if we replace x with 1, 1/3 to the 1 to the first power is just 1/3. 3 times 1/3 is 1, and the way that works, just in case you need to see it, 3 times 1/3. Okay, remember 3 is the same as 3 over 1, and these cancel out, becoming 1. So 1 times 1 is 1 over 1 times 1, which is also 1. Everything's just 1. And then when you replace the x with 2, 1/3 to the second power is actually 1/9. 3 times 1/9 is 1/3. And it would look something like this. There are your points. Negative 2 wouldn't show up in there, but negative 1 is 9. When x is 0, it's 3. When x is 1, it's 1. When x is 2, it's 1/3. And you can see how this kind of starts to curve and flatten out, but never quite touch there. All right, next example. One graph, will the following functions have a y-intercept? Easy way to do this is, and you don't even have to solve it really, you can just see if you'd be able to get an answer. We replace all of these with 0. So can I get an answer if I do 0 equals 5x minus 4? I would add 4 to both sides, which would give me 4 equals 5x. So yeah, I could get an answer here. So yes, it would have a y-intercept. What about this one? 0 equals 7 times x to the 4th power. Well, I'd have to divide by 7. Okay. 0 divided by 7. Remember, 0 can be divided by any number. That's fine. That works. All right. So you get 0 equals x to the 4th, which would just be 0. You can solve that. It's yes. Same with this one. It's the exact same type of problem, just different exponent. Now here's where it gets tricky. If we have 0 equals 3 times 4 to the x, okay, now you can divide by 3 if you want to do that stuff first, and you get 0 equals 4 to the x. The only way to get rid of this is by trying to square root both sides, and it's not going to work. So in that case, or you could just recognize and say, hey, there's no plus c to shift it down, so, or it would have to be a minus c. That would be the only thing that would shift it down when x is the exponent. Okay, there's a difference between having an exponent and x being the exponent. When x is the exponent, okay, unlike these, because we have actual numbers here, when x is the exponent, the only way to have an x-intercept is for it to be shifted down by minus c. So this answer would be no. All right, which of the following ordered pairs is on the graph of f of x equals 3 times 2 to the x? This is just as simple as plugging in and seeing if it works. So I could plug in, for example, 0 for x, and this for y. 3 times 2 to the 0 power. Remember, 2 to the 0 power, anything to the 0 power is 1. Does 6 equal 3 times 1? No. Again, you go through each one like that. What you'll end up with is the next one being true. Because if we plug in 24, let's see if that works. 3 times 2 to the 3rd. 2 to the 3rd is 8. Does 24 equal 3 times 8? Yes. So that one works. All right, next example. Graph f of x equals 4 times 1/2 x plus 1, and fill in the table with the correct value. So we're just going to go through and we're going to solve this. All right, so start off again by making your table here and just plugging in these numbers. 4 times 1/2 to the negative 2nd power. Remember, to make that positive, we're going to make that 4 times 2 squared. So that's going to be 16. Okay, and then just repeat 4 times negative 1, which would be 4 times 2 to the 1st power. 4 times 2, anything to the first power is just the number. 4 times 2 is 8. 4 times 1/2 to the 0 power, anything to the 0 power is just 1, so that's going to be 4. Now, you might notice a trend here. What's happening each time? We're dividing by 2. So you can actually, if you realize that, you can just say, okay, so I'm basically cutting it in half. So 4 divided by 2 is 2. 2 divided by 2 is 1. You can finish it off that way. So we have negative 216. It should be down a little bit. Sorry, these are, looks like this graph shifted, and it should, all these should be down 1. So that should be actually be down here. Oh no, wait, my bad. I totally skipped over the plus 1. So we had the 16 plus 1, which is 17. We had the 8 plus 1, which is 9. We had the 4 plus 1, which is 5, 3, 2. And that's what it's going to look like, roughly. It's not a perfect science. Your graphing calculator might help here, using the app on